All right, so what we're going to do in this video is we're going to learn about a concept called scientific notation. Now, you've probably seen this before in one of your high school or middle school math classes, and I'm sure for some of you it was very frustrating. So I'm not trying to get you to have terrible memories of math class from years back when, but I want you to try and understand that scientific notation is actually a reasonably easy thing to do if you understand it in terms of the rules or the laws of exponents, okay? So the way we write scientific notation is it's a number and then times 10 to a power, okay? So so the first part of scientific notation is we have a number that is either greater than or equal to 1, all right? Greater than or equal to 1, but it has to be less than 10, okay? So your number. And then another way of thinking about it is this, is the number will have a single digit that's not 0, okay, with a decimal point, and then it can have any number of digits after the decimal point. So for example, this first number could be like, 1.00375 or 45, okay? It can be 6.11231, okay? It can be 9.99987, okay? But it can't be 12.43672 because look, this number, the number that's to the left of the decimal, is larger than 10, so it can't be this. If this was going to be your scientific notation number, you would move that decimal point over here, and instead you would have 1.243672. So the number to the left of the decimal has to be a single digit, and it cannot be 0. So for example, if your number was 0.4367, well, you'd move the decimal point over here and you just make it 4.367. Okay? You cannot have a 0 here, and you cannot have a number that has 2 digits like 10, 11, or 12, or 57, or whatever. Okay? So the first part of scientific notation, what is it? It is a number that's between 1 and 10, but it can't be 10. It has to be smaller than 10. And it's usually a decimal number. And then the second part of scientific notation is times 10 to some power. So I'm going to say to the n power, okay? And that n power is usually not 0, but it can be 0 technically speaking. But if it was 0, then you just wouldn't write it in scientific notation because 10 to the 0 power is equal to 1. And so that would just be, if you're multiplying by 1, it would just be equal to whatever your number is. Okay? So here's an example of scientific notation. Let's say I have, 4.4398 times 10 to the 7th power, okay? Now, this power, this 7th power, it can be a positive 7 or it can be a negative 7. So I can have times 10 to the negative 7 power. Negative numbers, we're going to explain this in a little bit, but negative numbers basically make the number smaller. Positive numbers make this number bigger. But don't get too caught up on that right now. I'll explain it all in just a little bit, okay? So that's what scientific notation is. Now, you might be asking, why do we have scientific notation? Now, it's still useful if you're dealing in extremely large numbers. So if you have a number that's in the trillions or the quintillions, something with like 17 zeros after it, then writing it in scientific notation takes up less space, and it also allows you to represent a very large number without having to write the number out every single time. So now let's focus on how do we do scientific notation. So I am only going to ask you 4 kinds of questions in terms of scientific notation, okay? 2 of those questions are going to be to convert into scientific notation. The other 2 kinds of questions are going to be to convert from scientific notation. Okay? So we have two situations. We're going to start with a number, and then your answer is scientific notation. Then two kinds of questions where I give you a number in scientific notation, and then you turn it into the actual number. Okay. All right. So I'm going to give you a number that's larger than 10. Let's say 5,073. So let's say we want to convert 5,073 into scientific notation. All right. Well, here's what I'm going to show you my way. You can look up another video online and learn how to do it, but I'm going to show you my way. Here's what you're going to do. The first thing you're going to do is you're going to divide the number. Okay, so step one, divide the number by 10 to the power of n, where n is equal to the number of digits after the first digit. Okay? All right, so here we go. I'm going to divide 5,073 by 10 to the power of, well, how many digits are after the first digit? So I'm going to ignore the first digit, and then I have 1, 2, 3 digits. So I'm going to divide by 10 to the third power. So I'm going to grab a calculator, and I'm going to type in 5,073, 5073. Then I'm going to hit the divided by. Then I'm going to key in 10 to the power of 3. And I'm going to press enter, and it's going to become 5.073. Now, another way of doing this is just by simply moving the decimal point over until it's behind the first digit. 1, 2, 3, and we still get 5.073. And now the second step is to write that number, write that answer with the phrase with times 10 to the power of n, where n is the same n here. It's the number of digits after the first digit. So my answer here is going to be 5.073 times 10 to the third power, and I'm done. There we go. Two-step process. Very, very easy. 5.073 times 10 to the third power. I have just turned the number 5,073 into scientific notation. Okay? We'll do a couple more examples in just a little bit. All right, well, what about a situation where the number is smaller than 1? All right, so let's say that we've got the number so it's 0.00987. Okay? All right, so the first thing you're going to do is you are going to multiply the number by 10 to the n power again, but this time where n is equal to the number of zeros between the decimal point and the first non-zero, and then plus 1. Here's what I mean by that. What does plus 1 mean? Okay, well, how many zeros are between the decimal point? The first non-zero number is a 9. First non-zero number is a 9. Well, how many zeros are between the decimal point and the 9? Well, there's 2 of them, 2 zeros, right? So it's the number of zeros between the decimal point and the first non-zero, comma, plus 1. So I'm going to add 1 to that number. There's 2 zeros here, plus 1 is 3. Therefore, in this case, again, n is 3. So here n equals 3. And so step 2 is, okay, so we're going to multiply. We're going to multiply our number times 10 to the third power. Okay, so 0.00987 times 10 to the power of 3. If I do that right in the calculator, I get 9.87. Okay, so I've just turned my number into a value, into a number that has 1 digit here in front of the decimal point, right? Okay? Then, write that answer. Write that answer with times 10 to the negative n. Okay? So in this case, that's 10 to the negative 3. And so, I am going to write, for my answer here, 9.87, that's what I got in step 1, times 10 to the negative, and n was 3, therefore n to the negative, or 10 to the negative 3. And this is that number in scientific notation. Okay? All right, so what we're going to do now is we're going to learn how to convert from scientific notation. So let's say in scientific notation it's 10 to a positive power, and the second situation is where it's 10 to a negative power. So it's a number times 10 to the positive 7 power, or it's a number times 10 to the negative 4 power. Okay, what do you do? Okay, so let's say that in scientific notation, we'll do an example here. Let's say that we have 3.2668 times 10 to the 5th power. Okay? Well, really, here's what I would do. There's really only one thing that you have to do. You can just grab a calculator and type in 3.2668 times 10 to the 5th power, and that gives you 326,680. 326,680. Okay? Now, the old school way to do it, the way that you were originally taught how to do it, which works just as well, is you move this decimal point to the right 5 places. 1, 2, 3, 4, 5, and it would still give you, the decimal point's now over here, 326,680. But I figure, hey, look, if we have a scientific calculator, why not just type in what we're looking at, and that'll give us our answer, right? All right, so that is when it is a 10 to a positive power. All right, so now let's say it's 10 to a negative power. So let's say that we have 6.80433 times 10 to the negative 7 power. Okay? All right, I want to show you what this actually is. What we're really looking at here is 6.80433 times. Now remember what 10 to the negative 7 power is. It's 1 over 10 to the positive 7 power. So if we're doing 6.80433 times 1 over 10 to the 7th power, well, 10 to the 7th power, so what we really have is 80433 times 1 over, this is basically a 1 with 7 zeros. So there's 1 0, 2, 3, 4, 5, 6, 7. So it's basically 6.80433 times 1/10,000,000th. Times 1/10,000,000th, okay? And if you were to work this out algebraically, if we turn this into, or if we put parentheses to indicate multiplication, this would go into the numerator. What you'd really have is 6.80433 divided by 10 million. And so what I can do in the calculator is I can just type in 6.80433 divided by 10 million, or 10 to the 7th power. So divided by 10 to the 7th power, and I get, now here's the problem, is the calculator is now going to give me, here I'll show you, it doesn't give me the whole answer. All it gives me is 0.0000068. Okay, I don't know if I got the right number of O's in there. Okay, so here's what I'm going to do. I'm going to show you what you really need to do to be able to do one of these. So I did all that. I wanted to show you that the calculator doesn't always give you the whole answer, but you still have to be able to give the whole answer. Basically, what you're going to need to do is move this decimal point to the left 7 places. See, this negative symbol means that the number is becoming smaller. And a number always becomes smaller when the decimal point moves over to the left. Okay? And so we would move this decimal point over 1 place, then 2 places. Now look, we now have to put a 0 in here. We have to insert zeros. So we're going to put a 0 here. So that's 1, 2, 3 with a 0, 4 with a 0, 5 with a 0, 6 with a 0, 7. So now the decimal point is here. 1, 2, 3, 4, 5, 6, 7, and put a 0. And so our final answer is 1, 2, 3, 4, 5, 6 zeros. 1, 2, 3, 4, 5, 6. Whoops, not 6. 6 zeros. 5, 6. Then 680,433. 680,433. And that now is your final answer. Okay? So if we then take this number and go over here where our number is smaller than 1, well, this number is definitely smaller than 1. Remember what we were doing is we were adding up the number of zeros, but then doing plus 1. Well, let's see how many zeros we have here. 1, 2, 3, 4, 5, 6. Then add 1 more. That makes it 7. Then put a negative on it. Where is it? Negative 7. Okay? So let's do a bunch of examples right now. Maybe we'll do like 1 or 2 examples of each one, and then hopefully you'll have a better feel for this. All right, so we're going to convert this number, 607,445,810, into scientific notation. So we're going to take that number, 607,445,810, then we are going to divide it by 10 to the power of how many numbers, or how many digits there are after the first one. 1, 2, 3, 4, 5, 6, 7, 8. So it's divided by 10 to the 8th power. So I'm going to grab the calculator, and we're going to do 607,445,810 divided by 10 to the 8th power, and we get 6.0744581, and then we're going to put on there times 10 to the 8th power. Okay, which makes sense because we divided by 10 to the 8th power. Now if we multiply by 10 to the 8th power, it should put us back to the original number. And so there is the answer. All right, now I'm going to show you a situation where you can't really use the calculator method. And the reason you can't use the calculator method on such a large number here is because the calculator won't show you all of the digits. Okay? But the idea is still the same. We would multiply this, or excuse me, we would divide this number by 10. So we would take this number and we would divide it by 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. We would divide it by 10 to the 16th power, okay? Now, if you do that in a calculator, it's only going to give you digits over to here. It's not going to give you the whole number, okay? So here's what we're going to do. we're basically just going to write this whole number again, but the way we're going to write it is we're going to write the first digit, 1. Then we're going to put a decimal point. Then we're going to write the rest of the numbers, 8993, 733, 824, 961, 435. Okay? You basically just write the number again, but the first number, you put a decimal right after it, and then you just write the rest of the numbers, and then multiply it by 10 to the power that you got when you added up the total number of digits except the first one. So times 10 to the 16th power, and there we are, scientific notation. All right, so now it says convert this really tiny number into scientific notation. You can tell this number is smaller than 1 because there isn't anything in front of the decimal. Now sometimes there will be a 0 there and sometimes there will be nothing there. Well, if there's nothing there, that's the same thing as 0. Okay? So this number is smaller than 1. All right? And so we're going to have to do the other method, where what we're going to have to do is we're going to have to add up the number of zeros up until the very first non-zero number. So start at the decimal. There's 1, 2, 3, 4, 5 zeros. Add 1 to that. So now it's 6, right? So we know that we're going to be multiplying by 10 to the 6th power. But remember, it's not 10 to the 6th. It's 10 to the negative 6th power. And now you're going to write this number, okay, with the, starting with the 1, then put a decimal point. So 1 point, and then 98876. 98876, okay? Now, what I had explained to you previously, though, is that you can just type in this whole number, right? So this, let's go ahead, I just did the shortcut version. Now let's do the way that I explained before, okay? So we're going to put in 0.00000, so that's 5 zeros, 3, 4, 5, then 198876, okay, right? And then I said we're going to multiply that by 10 to the 6th. We're going to multiply by 10 to the 6th, so times 10 to the power of 6, and it gives us 1.98876. And then we say times 10 to the negative 6. Why? Because this number is smaller than 1, okay? So this is converting a number smaller than 1 into scientific notation. Let's do one more of those. Okay, so now we've got this crazy long number. Okay, now it's technically less than 1. How do we know the number is less than 1? Let's put a 0 up here because the number up here is a 0. So this number is smaller than 1. Therefore, we know that we're going to have the negative exponent. Okay, and in this particular case, we have to decide what number is going to go on the 10 as a power. Well, remember, we're going to add up the number of zeros here, which is 3. Then we're going to add 1 to it, and that's 4. So we know that it's going to be a 10 to the negative 4 power. We know that the answer is going to have a 10 to the negative 4 power on it. Okay. Now, if we do it the way where we just take this whole number and key it into a calculator and then multiply it by 10 to the 4th power, it's going to give us 2.5595 some other stuff, but it's going to round off somewhere. And therefore, when you have a lot of digits in your number, you can't use the calculator. So I'm going to give you a shortcut. The shortcut goes like this. Go to the first non-zero number, which in this case is a 2. Put a decimal point after that number. Then write the rest of the numbers. So it's going to be 2.5595 873,873,314 159236. Right? Times 10 to the negative 4. How did I know that it was going to be negative? Because the number is smaller than 1. How did I know it was going to be a 4? Because there are 3 zeros before the first non-zero digit, and I have to add 1 to that number, making it 4. Why am I adding 1 to that number? Because I got to push this number to the other side of the decimal point. So it takes 1, 2, 3, 4 to push the 2 over here to the other side of the decimal point. Okay? And that is converting numbers smaller than 1 into scientific notation. All right, so now here's a situation where you're given a value in scientific notation, and we want to know what is that value, okay? Well, you can see that this is our number. You can see that it's, one digit, then a decimal point, then a bunch of digits, okay? And it's times 10 to the 8th power, not -8. That means that this number is getting larger. If the exponent is positive, the number is getting larger. It's going to be bigger than 4. Okay? So if you wind up getting an answer that is smaller than 4, you did it wrong. This number has to be significantly bigger than 4. Now, one way I can do this is I can just take a calculator and key in 4.273182 times 10 to the 8th power, and I get, here's the answer that I get, I get 427,318,200. Okay? And note that the numbers that are written down in order here are the same as these numbers. 427,318, 427,318, then a 2, and then a 2, right? And what's going on here is the 8 indicates that the decimal point was moved over 8 times. It went 1, 2, 3, 4, 5, 6, and now to move it over 2 more places, we have to throw in 2 zeros. That accounts for these 2 zeros over here. Okay? So this number times 10 to the 8th, I was able to just do it in the calculator. But sometimes you might be given a problem where you can't do it in the calculator. All right, so look at this problem here. In fact, if you were to key this into a scientific calculator, you know what it would give you as an answer? It would actually give you this as the answer, although it would cut off somewhere around here. It would give you like the first 8 or 9 numbers, and then it would just say times 10 to the 15th power. Okay? Well, that's frustrating. So now the calculator's not going to be able to give you an answer. Well, that's why I'm here. I'm going to explain what we're going to do. What you're going to do is you are going to write all these numbers out, okay? But also you want to count how many digits are after the decimal. See, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That's perfect. If the number of digits is the same as your exponent, then all you have to do is write all the numbers out without a decimal point. So 121, 121, 04387, 04387, 699, 699, 237, 237, 48, 48, and then count. You got to put commas in. So starting from the end of it, you're going to come back every 3, 1, 2, 3 digits, put a comma. 1, 2, 3, 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 put a comma. And this is that number. Now, that's a crazy number. See, we've got million, billion, trillion. This is quadrillion. This is 1 quadrillion, 210 trillion, 438 billion, 769 million, 923,748. Okay? That is really, really crazy. Now I'm going to give you one that is just a little bit harder than this. All right, so we're going to try this. 7.9992 blah, 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 blah times 10 to the 14th power. Okay, now here's a situation where the 14, this 14th power, that's a larger number than how many digits are to the right of the decimal. Okay, so I'm going to count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 digits past the decimal, but this is a 14. And so what we then have to do is we have to take that 12 and subtract it from 14. So 14 minus 12 is equal to 2. What we have to do is we have to write all these numbers down without the decimal, write all of these numbers down in order, and then put 2 zeros on the end of all those numbers. So this would then become 799923, 799923, okay, 8476, 8476, 234, 234, and then because there are 12 digits here, but this is a 14, 14 minus 12 digits is 2 more digits. So we have to put 2 zeros in. We'll put in 2 zeros. Now we're going to put all the commas in. Come back 3 digits and put a comma. 3 digits, put a comma, 3 digits, put a comma, 3 digits, put a comma. And it looks like we have 799,847,623,400. And that is our number. All right, now we're just going to do 1 or 2 examples with the negative exponent. Okay, here's an easy one. We've got 5.3678 times 10 to the negative 4 power. We want to know what the actual number is. Well, because it's a negative exponent, that means our answer should be smaller than 1. So if your final answer is larger than 1, you did it wrong. Okay? This number, this answer should start with a 0.0. Okay? Or, well, not necessarily 0.0, but should start with a 0 point something, but probably a 0.0. Now, this one can actually be done in the calculator. I can just key this right in the calculator. 5.3678 times 10 to the power of negative 4. Press enter, and I get the correct answer, which is 0.53678. 53678. Now here's the thing. I know I can do it in a calculator if my answer, if the last few digits of the answer are the same last few digits of the question. But if the calculator had cut it off at 6 and my last 3 digits are 536, but over here is 678, that is a clear indicator I cannot do this one with a calculator. Okay? But this one in particular, I know that I can do with a calculator. And so the answer is 678. That is the right answer. We were able to do it with the calculator. Now I'm going to show you one that you can't do with the calculator. All right, so we're going to use the exact same starting digit, but instead of times 10 to the negative 4, we're going to do times 10 to the negative 9. If I key this in, 5.3678 times 10 to the power of negative 9, here's what I get. I get 0.000, here I'm just going to show you, 0.000000005. Okay, that's what I get. It ends with just a 5. So the last 3 digits are not 678, the last 3 digits are 005. That's a clear indicator to me that I cannot find my answer using just the calculator. Okay, so now we're going to have to do it by hand, which is pretty easy. Here's what we're going to do. To do it by hand, we are going to, first we're going to write, do you see this negative 9 right here? We're going to subtract 1 from the 9. Okay, well we're going to write 0 point, okay, so that's it. That's our first one. That's 1. That's our first 0. But now we need a number of zeros that's equal to this number, ignore the negative, 9 minus 1. So that's 8. So I know that I got to put in 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. Okay? Now I can write all of my digits. 5, 3, 6, 7, 8. 5, 3, 6, 7, 8. And that is my answer. Now, I said before, another way you can do it is you can take this decimal point and count 9 times. 1, 2, 3, 4, 5, 6, 7, 8, 9. Put a decimal point right there and put zeros in every one of these little loops. Okay, and now we have 1, 2, 3, 4, 5, 6, 7, 8 zeros, just like we put over here, and then the 5, 3, 6, 7, 8, and then that decimal point is gone. That's not there anymore. Okay, and so this is your final answer when you're doing scientific notation with 10 to a negative power. Okay, well that's it. That's all I really need you to do with scientific notation is be able to convert a number into scientific notation and out of scientific notation. And the only numbers you're going to be converting is either a number that's 10 and larger or smaller than 1. Okay? And let me know if you have any questions on the practice.